graph this line, let's put this in slope-intercept form. See how the x plus 3 is getting divided by 3? That means each term is getting divided by 3. So if I wanted to write this in slope-intercept form, there's a 1 in front of this x, so I would say 1/3 x, and 3 divided by 3 is 1. So this looks easier to graph than what it was originally, just by breaking it up into two terms. So to graph this, I do the y-intercept first, plus 1. And then from there, I'm going to do the slope, which is 1/3. That means up 1 over 3. So I go up 1 over 3. And I can keep going a couple times. I can go down 1 left 3 to reverse it. And there's my linear function. Okay. So now I want to do the inverse function. And remember, the inverse function is we're going to switch the x and y. So x equals 1/3 y plus 1. But we do want that in slope-intercept form so we can graph it. So let's solve for y. Subtract 1 first. And then to get y by itself, I don't want to divide by 1/3. I'm very good. I'm going to multiply by 3 over 1, which is 3. So I multiply both sides by 3. That means that whole thing's getting multiplied by 3. That cancels out, and I get 3x minus 3 equals y. And then I can graph that. That's my inverse. So I go down 3. I do my y-intercept first, down 3. And then my slope, which is 3 over 1, so up 3 over 1. So something to notice here is that if you did kind of sketch in that y equals x line, you should notice that that line was a reflection over that. So that's kind of one way to check yourself, is if you put in the y equals x line, it's a reflection over that. Again, you're going to graph the original function and then the inverse function. So if I wanted to graph 3 minus 7x, what do I graph first? The y-intercept. Which one's the y-intercept?
The 3.
The 3 is, okay? Even though the order's switched, you need to remember that m is always the number in front of x. So I'm going to go up 3, put a point, and then my slope is -7, which I can write as -7 over 1. That means down 7, right 1. So from here I can go 1, 2, 3, 4, 5, 6, 7, right 1. And then I can do the inverse function, and again the inverse function would be switch my x and y and solve for y. So subtract 3, divide by -7, right? And let's put that in slope-intercept form. Remember there's a 1 in front of that x, so I would have a -1/7 x. And then this is double negative, so that's going to become a positive 3/7. So that's my inverse. How do I go up 3/7? 3/7 is just less than half. So I'd go just less than half. And then I can go down 1, right 7. So down 1, 1, 2, 3, 4, 5, 6, 7. To reverse it, I can go up and left. 1, 2, 3, 4, 5, 6, 7. And again, if you sketch in that y equals x line right there, you should see it's a reflection over that. That's how you know you did it right. All right, so let's graph this quadratic by putting it into our graphing calculator. So y equals, and you're going to go 4x squared minus 2. And then graph it. You should see, yep, it's a parabola. Good. We need points to graph. So second graph would give us points, and you do want symmetry. That means repeated y values. And if you see, there's really only 3 points to graph. Otherwise, it gets too big. So -1, 2, 0, -2, 1, 2. So graph those 3 points, -1, 2, 0, -2, 1, 2. And there's my function. Okay. Now, to graph the inverse function, what's the easiest way? Flip the xy points. Very good. Okay, so to graph the inverse function, I can just flip those points. That's the very first thing we did on this lesson, was when you just flip the xy points, you get the inverse. So 2, -1, -2, 0, 2, 1, and you should see, yep, it reflected over the y equals x line. And it looks like that. However, I do want you to write the inverse. So even though you have it graphed, I do want you to still go up here and write the inverse. So let's switch my x's and y's. Solve for y. So we're going to what? Add 2. So x plus 2 equals 4y squared. Divide by 4. And then what? Square root both sides. Here's where radical lesson, last chapter, comes in. If I'm square rooting a fraction, plus or minus square root of x plus 2 over 2 equals y. Why? Because I square root the top, square root the bottom, and that bottom, square root 4, simplifies to 2. I can do that. Okay. One way you can check yourself on that, if you wanted to check yourself, maybe to see if that's correct. If you graph it in y equals, what's going to happen is that you are only going to get the radical function part. That means you're only going to get this top part. The graphing calculator won't do the bottom part. Okay? So you can just do that top part, square root of x plus 2 divide by 2. And see how you only have the top part, the radical function part? But if you go to your table, you should see 2, 1 is a point, and I have that on my table, and -2, 0 is a point, and that's also on my table. So the top half points should match your table points. Okay. So that's the rest of the lesson. The inverse function applications, we can look at one of those together. When you are doing inverse applications with formulas, inverse functions for a formula, you will not switch the variables. You keep the variables where they are. An inverse function of a formula is that you just solve for the other variable. That makes sense? So if this one where length equals half of weight plus 3, to get the inverse function, you're not going to switch the LW. You keep the LW where they are, and you're just going to solve for W. So the first part here, find the inverse model for the scale. I would take my equation there and just solve for W. So subtract 3, divide by half. So I'd get L minus 3 over 0.5. That would be my inverse function. And then, why do I have an inverse function? Because now if I have the length of 5.5, I can just put 5.5 in for L and solve for weight. It's easier to use the inverse function to solve than it would be the original function to solve.